So between router 6 and router 7, we got ISP. Our aim is to ping between our site only by layer 2 switching, not layer 3. That's the reason why, if you see, I don't have any IP address here. On provider side F00, there is no IP address. Likewise here also F00, there is no IP address, which means this entire rectangle box is going to appear like a switch for these two routers. Router 6 and router 7 is connected to a switch. It is connected to a VLAN. It is connected to a single broadcast domain. That is how you need to create a tunnel. A tunnel needs to make these ISP to appear like a switch for these two sites. Do you understand what I'm saying? Only when you have switch, you will be able to ping like that. See, only if this is a switch and you connect one router, another router on the same VLAN, and you will be able to ping from this IP to this IP because it's a switch. It's a layer 2 switch. Instead, if you have a layer 3, it's not possible. What is not possible? You cannot have same subnet. Here, if it is 10, definitely this cannot be a 10. It can be different number. Because what you do is you get routed here, go through the layer 3 tunnel, and then get routed here and go to the outside. That is layer 3. Routing is involved. We usually used to do what? Advertise the routes into VRF.
Yes.
That is layer 3. Here, nothing like that. This is as equal as we connect R6 to a switch and R7 to the same VLAN, same switch. 10001 can easily ping 10002 because it's a layer 2 switch. We are trying to make this to appear like this. Yeah, that's our aim. That's what we are trying to do. Today in our lab, what we are doing is just two sites, 6 and 7. In the next class, what we will be doing is multiple sites. Same customer, multiple sites. That is VPLS. This is VPWS. What we are doing is VPWS, Virtual Private Wire Service. It's like a wire, single layer 2 wire connecting these two. VPLS, Virtual Private LAN Service, where you will have multiple devices in the same layer 2 switch, multiple sites. In our case, right now, we are doing only two sites, which is VPWS. Right. Now, as usual, we go and enable routing and MPLS, after which we will create Xconnect, which will use MPLS as an encapsulation and form a tunnel with a remote PE. So this is going to be our PE1, and this is PE2. So between these two PEs, there's going to be a tunnel negotiated with MPLS as an encapsulation. So whatever the packet that is coming in will be encapsulated with the label and it will be delivered here. And when it is delivered here, it will just go out this way. Please pay attention. This is something different from what we were doing. In our previous layer 3 VPN, this mouth, the VPN mouth, this mouth was here behind P, but now it is in front of the P. It is facing the customer. So whatever customer throws, it need not to go to the routing table. It goes straight into this tunnel and get delivered, go out of the tunnel, and it hits only on the router on the customer side. So if a layer 2 ARP broadcast is sent, it will go straight and hit on router 7 only. If ARP is sent from R6, if ARP request, which is a layer 2 broadcast sent from R6, it will go and hit only on R7. Because the tunnel opening is facing the customer, not the provider. It is facing the customer. And I told you there is no need for an IP address on the customer facing interface on the provider router. There is no need for an IP address on the customer facing interface on the provider router. Okay, so let's begin this. These are the IP address that we are going to assign. This is the IP plan. Let me get the console. What is this? It's showing as a switch. I'm sorry, I made a mistake. It is okay. We can have a layer 3 interface. There's nothing wrong in it. Host name, I'll say router 1 or router 6. Interface Ethernet 0/1. You know very well that when I say no switch port, it becomes a routed port. I can put IP address here. 10.0.0.1. Right. Now this is the same like router IP routing. This command we have to type. Done. I should see root, show IP route. Okay. Likewise on R7, I want to finish. Right. Our ultimate aim is we need to ping between R6 and R7. Right now, if you see show ARP, there is no MAC address for 10.0.0.1 here. For that, you need to bring up the tunnel first. Let's bring the tunnel up. I'll start from this router here, which is our PE. Okay, I'm in our road. I'm going to host, say, just PE1. And as I said, we will give IP address only on the interface that is facing the provider. Interface F1/0. 10.1. And then I'm going to say MPLS. Wait, let's take some loopback. Interface loopback1 IP address. The reason why I'm configuring loopback is MPLS needs a router ID. If you don't have loopback, it will pick some physical interface which may confuse you. So I'm giving loopback. MPLS IP interface F1/0 MPLS IP. Now there is nothing more to do here. Okay, we need a routing between PE1 to PE2, which is here, PE to this PE2. We need routing between the first router to the last router. So let's enable OSPF also. What happened? Why is loopback coming now? Show IP interface brief. Oh, I gave one earlier. No problem. Interface loopback 0. Interface loopback 1. IP OSPF 1 area 0. Interface F1/0. Right. Now show IP OSPF interface. Okay. Now what I'm going to do is I'm going to go to this router P host name R5 or PE2. Interface loopback 1 IP address is 2.2.2.2. You cannot put MPLS. IP OSPF 1 area 0. Interface F1/0. You need to focus here. We are not doing anything on F00 now. I'm giving 40.2. Okay, IP OSPF 1 area 0. MPLS IP. MPLS label range. This is for provider. No, I'm going to say 500 to 599. Use this range. All right. Going to first router to set the range. MPLS label range. As we all know, this is not a mandatory command. We just want to know from where the label is coming when we troubleshoot or trace route. So we are giving this range. Now, this is provider router. Host name, I would like to name it as P1. This is P1. This is P2. This is P3. P1 Interface loopback 0 IP address is 2.2.2.2. Interface F00. MPLS IP. I'm expecting even MPLS OSPF has come. I'm expecting a LDP neighbor. Okay, LDP neighbor has also come. Right, moving on to the third router, which is P2. I'm going to the other side of that router. Okay, now what is next? I would like to check whether the configurations are correct. Show IP OSPF interface brief. Okay, OSPF is running on F00 and F01. Cross ID ready, everything is looking great. But I think I have something to do on this P1. There's one interface missing. I'm expecting MPLS as well as OSPF neighborship with R3, which is PE2. Okay, OSPF has come. This is 3333 router 3. I forgot to give the range. I would like to give the range. MPLS label ranges. This is going to be 300, 399. I'm just refreshing MPLS. Okay, so next is only one router left. And then we put IP OSPF1, it is 0. Interface F1/0. We put notion already. IP address is 192.168.30.2. MPLS IP OSPF 1 area 0. Interface F0/0. IP address is 192.168.40.1. Zero. MPLS label range. Right, I'm expecting two MPLS neighbor here.
Two has come.
Show MPLS LDP neighbor. I'm seeing 4 talking to how come to what's the address on router P? I need to change the loopback. Show IP interface brief. I do not want to have 22222 because 2222 we have already given here on this router also we have given. Yeah. So on PE I'm going to change interface loopback 1 IP address as 5.5.5.5. So I'm going to say to OSPF clear IP. Okay, the router ID changed. Now on R4 I should see two neighbor, one is 3 and another one is 4. Sorry, 5. Show MPLS LDP neighbor, I should see 5 and 3. That's correct. Alright, and did I give range? I think I gave range. What is this? Right. So let me first of all verify the trace route 5.5.5.5 the source of I want to see labels. Okay, label number what? Label number 21? I need to restart the MPLS there. Okay, this is correct label 3. And then I'm expecting 400. Some label 400. Okay, good. And then PHP. Okay, good. So on router P1, range. I want to clear MPLS, no MPLS IP. Right, one more time if you trace, the labels will be nice. It will be like 200. See, 203. So these are all well-known stories for us. Now, what is the new story? I can form a tunnel between F00 to F00 of PEs. I can form tunnel in between like this. And the tunnel will be starting from F00 of PE1, F00. Whereas in layer 3 VPN, the tunnel was on the other side, F01 of PE1. F1/0 of P1, F1/0 of P1. All right, now what is next? How to form this tunnel? Please pay attention, this is the interesting part. I'll go to router 5 and configure first. Router 5 is PE2. Interface F00. See, we don't have any VRF now, IPRS, not even an IPRS on this interface. We say no switchboard. And then I'm going to say X connect. What is the peer address? Means, the reachable address of the other PE. What is that? 100. What is the virtual circuit ID? See, this ID must. How many must I said? 6 must. Which means very important to match on the other side. When you configure on the other router, make sure whatever the number that you give here matches. I'm saying VCID, virtual circuit ID is 15. I can give any number. Now, what is the encapsulation that you would like to use? MPLS. That's all. That's all. Now I need to repeat the same on the other PE. This one. Config T. Interface, the customer facing interface. No shutdown. X connect. Can someone tell me what should be the peer address? 5.5.5.5. What should be the virtual circuit ID?
15.
Very correct. It should not be changed. Encapsulation MPLS. That is all you need to do. And you see, did you see that? Did you see that? You should see that. You should have said wow by this time. You can see PE1 forming neighbor with 5th router, which means the tunnel is up. The 1st router and 5th router has got a wire, a virtual wire. That's why we call it as VPWS, a wired service. How do you verify this? Show X connect. Virtual circuit show X connect. Peer is 5.5.5.5. Virtual circuit ID, VC ID 15. Now you see, it is up. It is up. Both the side it is up. It's an encapsulation of MPLS. You see, this is the VC ID. You may have multiple virtual circuits between the same router for different customer if you have multiple customers. Right now we have only one customer on this P. So no need of VRF, because this VC ID is what going to be identifying the tunnel endpoint. Now what sort of tunnel it is? Is it a layer 3 tunnel? No, it's a layer 2 tunnel, Ethernet. Alright, now let us go and verify the reachability. Earlier when we were checking show ARP, I'm not able to see 10002, but now after pinging 10002, see, I should be pinging. Look at this, look at this, look at this. R6 is pinging R7. If it trace route, it will be just one hop only, because it's a layer 2 tunnel. Just only one hop. It won't show all your MPLS. It will not show. It's a layer 2 tunnel. Just it's going to be only one hop. See? Straight. It's there. Only one hop. Now, I would like to show the ARP table now. Show ARP. I see the MAC address of the remote device. Let us go and check whether the MAC address of R7 matches. Show IP interface Ethernet 00. No, not IP, just cut the IP. Now, if you go up, you will see the MAC address of the ARP table matches. See? ABBCC 007000. This is what? VPWS. Virtual Private Wired Service, a layer 2 VPN. Here the important thing that you need to focus is encapsulation and the VCID. That's a very important thing. VCID is what going to be acting as a target here to say where the packet needs to be delivered. And there is no IP address involved here. It's only the label that is moving the packet. That is why when I trace route, you are not seeing any hops there. Just one hop between R3 and R7. Only one hop. R6 is seeing R7 as the immediate router. R6 is seeing R7 as immediate router. Do you remember I draw a diagram like this? R6, R7. Here it's like a layer 2 switch. Right? That's all for today.